Welcome to the video explanation of Programming Lab 1. In this video, we will discuss about recurrence or looping in C++ programming language. Recurrence or looping is a process that executes statements in a program continuously until there are conditions to stop it. And the looping structure really helps in program efficiency. There are three types or three structures of looping in C++. First is for. For is used when we know the number of iterations, or how many times the loop will be performed. And the second is while. While is used to repeat the statements as long as the condition is true. And the third is do while. Do while is almost similar with the while loop, but the condition in the do while loop will be checked after the statement is executed. If the condition is true, then the statement is executed again, but if the condition is false, the statement is not executed. First, we will discuss about looping structure for. For is used to execute the looping statement if the condition is true by defining a variable as its index and know the number of iterations. So we can use the loop with counter. The data type that used as index must have regular order. For example, integer from 0, 1, 2, and so on. And we can use char data type like A, B, C, and so on. The general form of for looping is for initialization, condition, and then increment or decrement, and then continue with statement. Let's discuss all the parts of for structure. First is initialization. Initialization is used to provide an initial value for the counter variable, and it executed only once. And the second is condition. Condition is something that evaluated by the program. If the value is true, then the loop continues. Otherwise, the loop stops and statements are ignored. And the third is increment or decrement. Increment or decrement is executed to update the value of variable. It will increase or decrease the value of variable. And the last is statement. Statement is something that will be executed by the program. It can be a single instruction or a block of instruction in the sign of curly bracket. Note that initialization and increment or decrement are optional. So we can create a program that only uses the condition without initialization and without increment or decrement. But it's important to concern about the condition and initialization of the loop so we can avoid an infinite loop. Note that if we perform an incremental loop, the initial value of the defined variable must be less than the final value that is written in the condition or expression. This is the example in incremental loop. We can use for and then the variable, and then we add the initial value and then the condition and then increment, so we use variable and then plus plus. Otherwise, if we perform a decrement loop, then the initial value must be greater than the final value. And this is the example of the for structure. For and then variable and then equal sign, initial value, condition, and then variable minus minus. It means that the variable will be decreased. By default, the for structure increase or decrease the index variable by the value of 1. If we use variable plus plus or if we use variable min min, it just increase or decrease by the value 1. If we want to increase or decrease the value by another value, the increment and decrement operators are replaced with self-defined statement. And this is the sample program to use for structure. In this program, we use integer c and then integer c. The variable c is used for incremental loop and the variable g is used for decremental loop. For incremental loop, we can use for and then we initial the value of variable c is 0 and then the condition if c less than 5 and then the increment c++. It means that the value of c will be increased one by one. And then we see out the value of c and then enter. And then after the looping is done, we see out increment done. And then for the decremental loop, first we initial the value of g is 5 and then the condition if g more than 0. And then for the decrement g minus minus, it means that the value of g will be decreased one by one. And then we see out the value of g and then enter. Then after the looping has done, we see out the statement decrement done. And this is the result of this program. We print incremental loop and then we print the value from 0 until less than 5, it means that 4. And then increment done. And then for the decrement from 5 until g more than 0, it means 1. And then cout decrement done. Next, we are going to discuss about looping structure while. The type of while looping structure is a loop that checks the condition at the beginning of the structural block. While is used to repeat the statement if the expression or condition is met or the value is true. The general form of while looping structure is while expression and then statement that will be repeated. If the expression or condition is met or the value is true, then the statement will be executed. But if the expression is false, the statement is not executed. This is the sample program to use the while looping structure. In this program, we want to calculate the factorial of the number that inserted by the user. First, we initial the variable number and factorial. Factorial is 1. And then cout enter a number to calculate the factorial. And then say number, so the user can insert a number. And then cout number factorial sign, and then equal sign. Well, number more than 1. And then we calculate the factorial by this statement. Factorial, start, equal sign, and then number. It means that we calculate the factorial by factorial and then multiply by c. If the number not equal with 1, cout number and then add with the x letter. X letter equal with the multiply sign. And then else cout number equal signs. So if the number is equal with 1, so we will print number and then equal sign. And then number minus minus, it used to decrease the value of number variable. And then we cout the factorial result. And this is the output. Enter a number to calculate the factorial, and then the user insert 5 number in here, and then 5 factorial equal with 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 and equal with 1020. Then we will discuss about looping structure do while. Functionally, do while is almost the same as the while loop. However, the condition in do while is evaluated after the statement is executed. If the condition is true, then the statement is executed again. But if the condition is false, the statement is not executed. In the other words, statement is executed at least once even though the conditions are not met. The general form of the while looping structure is do and then statement that will be repeated and then while condition. If the condition is true, then the statement is executed again, but if the condition is false, the statement is not executed. And this is the sample program that uses the do-while looping structure. This program is used to get the greatest common divisor or GCD from two numbers. First, we need to declare the variable number 1 and number 2, and then we add the remainder variable to save the result of remainder if we divide two numbers. And then cout enter the first number, and then the user insert the first number in number 1 and then enter the second number, and then the number will be inserted in number 2 variable. This line is used to swap the value to make number 1 is greater than number 2. So if number 1 is less than number 2, so we will swap the value of number 1 and number 2. And then do set the value of remainder with the result of number 1 modulo with number 2. And change the value of number 1 with the value of number 2. And then change the value of number 2 with the value of remainder. And then while and then the condition, we check the condition. If the value of remainder is not equal with 0, then we execute this statement again. But if the value of remainder is 0, the statement is not executed. And then we print the result. The greatest common divisor or GCD is equal with number 1. And this is the output of the program. Enter the first number, and then for example the first number is 36 and the second number is 60, so we have the greatest common divisor is 12. Next, we are going to discuss about nested looping. Nested looping is a loop inside another loop. The deeper loop will be processed first until it finishes. Then the outer loop will be increased. After that, we continue to execute deeper loop again, starting for the initial value. Then the outer loop will be increased again, onwards. Loops within loops are allowed in most programming languages. The example of general form of looping structure is shown in this slide. In this example, there is for loop inside another for loop. All forms of looping can be put on another looping form. So we can put for loop inside the while loop. And this is the example of nested looping. The sample program shows that we can use for loop inside the while loop. The statement will run as many as nested 1 multiplied by nested 2 according to user input. Let's discuss the process of this program. First, we initial nested 1, nested 2, and then the value of initial 1 is 1, and then initial 2. Then the value for nested 1 and nested 2 variables inserted by the user. And then if condition will check whether the value of each nested is a positive integer or not. If the value of nested 1 and the value of nested 2 are positive integer, then the while loop will be executed. Inside the while loop, the condition will be checked whether the value of initial 1 is less than the value of nested 1 or not. Because the condition is true, the statement inside the while loop is executed. Inside the while loop statement, there is another loop again. Then the looping condition is checked. We need to check if the value of initial 2 is less than or equal to nested 2 or not. If the condition is true, then the for statement is executed. The statement displays a message to the screen, iteration, and then dash, and then the result of initial 1 multiplied by initial 2. For statement will be executed until the value of initial 2 more than the value of nested 2. For example, if we insert the value of nested 2 is 3, so for loop statement runs 3 times. Furthermore, if we insert the value of nested 1 is 2, then the while loop statement is executed as much as 2 times. In conclusion, the total statements that execute by this program as much as 6 times from 2 multiplied by 3. You can see the program output on the right side. So from this program, it will display a message to the screen iteration 1 until 6. We have discussed the various looping structure and nested looping. Then we will discuss regarding bifurcation and jump. First is break instruction. By using the break instruction, the program exits the loop even if the conditions for ending the loop are not met. Break instruction can be used to end an infinite loop or to make a loop to finish immediately. The looping process and the program will jump directly to the statement under the block of the loop. This is the example of sample program. So in here you can see that we use n variable. First we need to declare n variable, and then for the looping structure we use for. The initial value of n is 10, and then the condition if n more than 0, and then the decrement n minus minus. So it will decrease one by one. And then for the statement we see out the value of n and the comma sign. If n is equal with 3, and then we see out countdown aborted, and then we add break instruction in here, and then see out the value of n, and then display the value of n. On the right side you can see the result. This program will display 10 until 3, and then the countdown aborted, the value of n is 3. It happened because if the value of n is equal than 3, the program see out countdown aborted, and then in here there is break instruction, so this program not continue to print the value of n until 1. So the countdown aborted, and then print the value of n is 3. The second instruction is continue instruction. The continue instruction causes the program to skip the next step to the end of the block in the loop. In the other words, the program immediately jumps to the next iteration. This is the sample program to use continue instruction. In this program we use for structure, and then the initial value of n is 10, and then the condition n more than 0, and then the decrement n minus minus. If n is equal with 5, and then continue, cout n, and then comma sign, and the last cout done. You can see the result of this program on the right side. So you can see that this program will display the number 10, 9, 8, 7, 6, and then skip the value of 5, and then print the value of 4, 3, 2, and 1. So when we use the continue instruction, the program will jump immediately to the next iteration. And the next we will discuss about the goto instruction. The goto instruction causes jumps in the program. The goal of the jump is identified by a label, which contains the arguments. The syntax for writing labels is followed by a colon. This is the sample program to use goto instruction. First, we declare that the value of n is 10. And then this is the label is loop, and then the argument is cout n, comma, and then n minus minus. If n more than 0, go to loop. So this program will jump to the loop label. and then cout fire. And on the right side, you can see the result. Because the initial value of n is 10, and then if n more than 0, and then go to loop, cout n, comma. So it will print 10, comma, and then the value of n is decreased by 1. Now the value of n is 9, and then go to loop again. So cout 9, comma, and then the program will decrease the value of n. So the value of n is 8. If the value of n more than 0, the value of n is 8, so go to loop again and so on. So we can print the output is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1, and then cout fire. Well, we have finished discussing the various looping structures, nested looping, and continue to discuss about bifurcation and jump instruction. We have also seen the sample program for different problems. I think enough for our discussion on this topic. Thank you for watching and see you on the next video.